Picture this, you are a leader in a small town and you have the power to decide where to invest your resources. Do you go all in one project or do you spread it out to benefit everyone? In today's episode, we are tackling a unique challenge that illustrates the complexities of development and the impact of your choices. Join me as we break down the math behind making the smartest decision for your community. Alright, let's dive into the problem at hand. We're tackling a challenge where we need to figure out the most efficient way to connect cities with libraries and roads, minimizing the overall cost. So what exactly we are working with? We have a number of cities and for each city, we either build a library or a road to connect to another city. The twist is that the cost of building a library and the cost of building a road can vary. Let's break down the problem step by step. First, we need to consider the cost dynamics between building libraries and roads. If constructing a library is cheaper than or equal to the cost of building a road, then our strategy is straightforward. We build a library in every city. Why? Because it's more cost effective and every city will have access to a library without the need for roads. But what if building a library is more expensive than building a road? This is where things start to get interesting. Imagine you have several cities connected by road forming clusters of components. In this case, we leverage the roads to minimize the cost. The key insight here is that we have a connected component of cities. We only need to build one library for that entire component. We'll then build roads to connect the rest of the cities in that component to the library. This means that for each connected component of cities, the total cost will consist of one library and the number of roads equal to the count of cities in that component minus 1. Now moving on to the next concept, how do we identify these connected components? We can use graph traversal technique like DFS or BFS. Essentially, we'll build a representation of our cities and cost and roads using an adjacency list. The structure allows us to keep track of which cities are directly connected. Here's how the process works. We'll iterate through each city, and if it hasn't been visited yet, we'll initiate a DFS from that city. The DFS will explore all reachable cities, marking them as visited and counting that number to determine the size of the connected components. After determining the size of each component, we calculate the cost for that component using our earlier insights. One library plus the cost of the roads needed to connect the remaining cities. Finally, we sum this cost for all components to get the total cost. So now we have a clear approach of compare the cost of building libraries and roads. If libraries are cheaper or equal, build them in every city. If roads are cheaper, construct an adjacency list to represent city connection. Using DFS to find connected components, calculating the cost for each, understanding the problem deeply and breaking it down into manageable steps is crucial. It's not just about writing code, it's about building a solid foundation that will guide our coding process. Check out the link in the description below for the complete source code. So what are the key takeaways? First, always access the cost implications of your choice. Second, understanding data structures like graph can significantly enhance your problem solving toolkit. And remember, efficient traversal methods like DFS are your friends. If you've enjoyed this explanation, don't forget to hit that like button and subscribe for more programming challenges and solutions. Until next time, keep coding and stay curious.